technology, so you can deploy them into a more austere setting. You still need a medical technician to apply the test under the current rules, under the current way it's being regulated. But you can push it into, for example, a school and have a school nurse administer it, or have a nurse administer it in a workplace. So I think it's going to get more wide use. And even though it's not approved for routine screening of an asymptomatic population, you heard the CEO saying they're collecting additional data to prove that utility of the test. I suspect it's going to be used that way right out of the gate. And the sensitivity will go down as you use it as a screening tool for an asymptomatic population. But given the very high sensitivity of the test in a symptomatic population, you'd still expect it to be a pretty good tool for those purposes, especially given the price point and the ease of use. So this really is going to be a meaningful change in the market. You have to give Abbott some credit for investing significantly in manufacturing and coming to market with really substantial manufacturing. I think the only question is how much of the existing runs of this product have the federal government cornered. And we know the federal government stepped in with a big contract to purchase 150 million of these. And so it's not clear to me how much is going to be available for the private supply and private supply chains, and how much is going to be cornered by the federal government and reallocated to schools and nursing homes, which is obviously an important use, but there's going to be other people who want to get their hands on this.
You mentioned the sensitivity, and we showed the specificity numbers as well. I guess that points to the accuracy level, because the concern with these cheap, fast tests that don't require labs and aren't the traditional PCR tests was always the accuracy levels and whether we could really trust the data coming out of them. How does this Abbott test look to you, and how much development have we seen on this front with these fast tests?
Yeah, so the sensitivity points to how likely is it to identify infection if in fact you're actually infected, and the sensitivity is very high. The specificity is high as well, and that speaks to how likely is it to read out an appropriate result. So if you don't have coronavirus, how likely is it to say that you do? That relates to the specificity of the test, and that's high as well, especially for a screening device of this kind. Some of the other antigen-based tests that are in the market that are perfectly good tests used in doctors' offices have sensitivity of around 80%. And so for such a simple device and an inexpensive device, this is pretty good. I would expect to see other approvals happening in pretty short order. What happens with these kinds of approvals with the FDA typically, and this is just typical, is they come in waves. And so you saw the agency initially back in February start to approve in March the PCR-based platforms. That was sort of the first wave of platforms used in large labs. Then they started to approve the antigen-based tests that were hardware, that were in doctors' offices, like the Sophia 2 or the Abbott ID Now or the Becton Dickinson Verita system. Now they seem to be moving on to these sort of point-of-care lateral flow tests, these paper-based tests. And I would expect to see other manufacturers that have had these tests in development and under review in the agency to start to get their tests authorized as well. Obviously, Abbott was the first, but there's going to be more supply probably coming into the market from other manufacturers.